Hello YouTube, Brian Phillips here again. I'm here to do a couple of mods on the Phoenix today, but I wanted to show you I upgraded my storage, which was ridiculous. And as you can see, the Airbus is kind of a big one. I made this little swiveling bracket that holds it, and I had to rearrange a lot of these planes. It's getting a little tight in here these days, and I know sometimes you guys ask for videos to show what I do with my planes. So it's tough because they take up a lot of room, and then the commercial airliners seem to be the worst for storage. So anyway, without further ado, we're going to look at this one here. You can kind of see the way that works. We've got these little foam blocks that just swivel, and I just hold those on with these bolts, and these bolts extend up and they hook onto my previous U-bolt. The U-bolt wraps around and they're just zip tied together, and then they come off of these brackets. The Airbus A330 is big, so I had to make some pretty long strange brackets to hold that one. And then I had a bunch of these U-bolts left over from a project that basically they weren't quite long enough on some planes, but like I did this here, I staggered those up and I just zip tied them on. So all these planes are held up with like 2 zip ties, hold on to the 2 zip ties, which hold on to the 2 zip ties, which hold on to the 2 zip ties, which hold on to one set of screws. So hopefully those screws are sufficient, but you got to keep in mind screws will hold up a lot of weight. So anyway, all these planes are just suspended from the ceiling, and I just used a series of U-bolts. Initially I had worked off of these. These are brackets. This is we use a pair of these to mount these cables on some of these scales, and it's like the leftover one that never seems to quite work out. They give us both configurations. So I wanted to give you guys a quick shot of that real quick before we get started today. And what we're going to be concentrating on today is this rudder. We've got this play here. We're going to eliminate that. It's going to be pretty simple. I've seen that a couple other guys have done some stuff, and I'm just going to do something that's maybe even a little bit easier than what they've done. But I think it's going to be a really, really easy thing for you guys to copy. And I just wanted to elaborate on this hot glue that seems to be kind of a I don't know if it's a hot button item, but having a little bit of glue in here is certainly not going to be an issue for weight. The center of gravity works out fine, although having an evenly distributed mass along the length of the fuse, some people think that that's a big deal. I don't really care. I don't think it's a big deal. But what I'm going to do is I'm going to go ahead and, I mean, how many times have you guys seen a lead weight that's way up here, or a lead weight that's way up here? It's not like a lead string that goes like this. So as far as I'm concerned, if the thing pivots on the right point structurally, then it's going to work well. So we'll go ahead and get that done. I'll show you how I'm going to do it. Now, I have the added advantage of having already installed 3 hinges because I accidentally broke this off at installation. So you can go back to one of the build series videos, the early ones, and you'll see how I did that if you want to copy along. And then the only thing that's holding me up on doing this is that I actually might need to pull a wire through this hole for the lights. I'm not going to do anything too dynamic here on this system. I'm just going to be doing a tail light that's probably going to be glued here. I don't even think I'm going to carry out to the tail because there's not really a big advantage on this plane. And then on this plane you can see the wing kind of hiding there in the middle. It's so long I don't disassemble it, so you can see it right there. There's the end of it, and there's the beginning of it. It's actually the same length as this ASH 26, and that one goes way over there and then way over to here. And so that's part of the reason why I keep that assembled. I'm going to be doing a red and green light on those winglets, sharklets, whatever you want to call these things. And they're going to be probably right here. And the reason for going there is for visibility from as many angles as possible. And then when you're flying at level, I want to be able to see that hint of light as the wing breaks behind the fuselage. So that's my rationale there. We're going to try to get all that stuff done in the next couple of videos. And for today, we're going to start with probably doing the tail light, which is a little bit out of the ordinary for me. And that's just because we're going to need to put this hinge in. So we're going to get those things in order. And once we're done with that, then we can go ahead and get our decals applied. I've got a design I came up with. It's really simple. And I might just use it on the bottom, and I might use the stock decals on the top. Not 100% certain on that yet, but one way or another, you guys keep watching, you'll see. So without further ado, we're going to go ahead and get started on that LED, then we're going to do the hinge. So first step when I do these LED projects is very simple. I bought this a long time ago. It lasts forever. Is this little it's motor winding wire. So it's an enamel coated magnet wire. That's what they call it. Now, as you probably have already thought about, Radio Shack is largely out of business for their retail outlets. You can get this stuff all over the place from electrical supply houses, and you can see how there's kind of 3 different sizes. I use the smallest size that I can get away with. Okay. Now, I don't always use this stuff. Sometimes I use an alternative method. And the reason I go over this again is because it seems like every time I do a video on LEDs, somebody asks me what kit I used. Well, I have used kits. I have a kit like this. I think I've got a link in my stuff to buy to support me that's like this. May not even have the Turnigy brand. It might be branded under somebody else, but it's all the same crap, guys. It's got a little controller like this. I don't use that. I just pull power from my servos, and then I guess and check until I get the resistive value so that the output of the lights are very similar. I don't even do math because I don't know what the math is because I didn't buy the LEDs. And I put it on my breadboard and so on and so forth. So that's the plan. For the wire I'm going to use on this plane, because we're not super weight sensitive, these little dinky wires, these are free to me because I get these serial patch cables. When I go into a work site, sometimes I'll see these recycling bins where they have like old computers and stuff and keyboards and junk like that. Well, when's the last time you've had a 25-pin parallel port? Probably never for most of you young people. Or one of these cables, okay? Which is an old printer style cable. If you cut that open, you're going to get a cable that's like this. Because every one of those wires is landed. Now, when I build cables at work, this is an SVGA cable. It's got 12 conductors. So, perfect for this sort of thing. The only problem with SVGA cables is you end up with these weird coax-style cables, which, of course, have a very thick sheath and then a very small copper line that's solid. This is better because it's a braided, copper-based wire. Okay, and you're going to have pairs. So that works out really nice. So what I'll do is I'll basically take a suitable pair from whatever bundle I've got cut open, and if I don't have enough, or if I need it to be longer, then I can splice them together, which I've never actually needed them longer than this. If it's going to be mounted on a wing where it's seen, I'll try to kind of be careful about what colors I pick. But like in this case, I've got a red, so I'll keep and reserve that for when I do the red light. And I have a green, and a green with black, so I'll use that for the other light. And I have a red with black, which I see here, and I'll actually go ahead and use that. And if you just grab 1/2 of those, and then you take and reach in and hold the rest of these. I've got them on screws like this. Sometimes they'll pull out, but usually they don't. So I just pull it off the screw. But these things are kind of braided in that cable, so once you strip it all out, then it can be a little bit tedious to separate just the wires you want. But that's exactly what I do, is tedious. You guys should know this by now. So I'm going to separate those wires out and hold those off to the side. Now, why use this instead of that enamel coated wire? Well, because this is extremely light. It's also extremely hard to work with compared to this wire. Okay, so we're going to lay this out. The first thing I do once I get my wires picked is I will grab one of them and just validate that they're going to be long enough. Now I have my wing up in the air still, and that's fine. Let's say we go from here, we can see where the first servo is going to be. It's going to be on this control surface, so that's really where I can reach to. And especially on a removable wing plane, if you can tap the power from the BEC, which of course is going to be going out to each of your servos, then it's always nice because then you have one less connector to connect when you put your wing on and off, you know, when you're transporting it. So that's definitely a good thing. Now the other thing is, this wire, of course, you can usually get more than one shot out of each set. So I'm just looking through the colors that are available. And of course I've used these on other projects before, so I'm not... When I first opened it up, there's tons. But I do like using the pairs if I can. It's like this is like a pink with a black stripe and then a pink. So I'll go ahead and use that pair to get my tail light done. Because it's going to be inside the cavity. In fact, that makes me think. I don't ever use blue for anything, so I'll use the blue and black. Because it's going to be hidden. The ones that go down the wings, if you have white, white is nice because it'll blend it a little better with the plane. And it won't show through any decals. Although my decal design is so simple that it's probably not going to be of any value. So we got this blue and then the blue with black. So now why do we want to have them designated as blue and blue with black? Well, this is pretty easy stuff. You're going to do that so that you can keep your polarity straight. Okay. So my next step is to get the soldering iron hot and get some LEDs ready to land on the end of my blue and black wire. Alright folks, so we got the soldering iron getting hot. And these are the lights that we're going to use for the white. They're made by GE. These are actually lights that my father-in-law got out of a sign. It was a backlight, and this is what it looks like on AC power. I have those mounted. There's a little power supply here that runs a number of them. So this is what we're going to be using. Of course, we're not going to be using them through those three-way. You can also buy these, very similar variety. I have used these ones, and they actually work well for the colors, but as I get them, I go ahead and cut the strips off and just use them like this. So as I consume them, I just use 1 or 2 or 3 or whatever it is at a time. So then I always have this drawing I go back to. It's just one of the first ones I found. So the nav lights are going to be red and green on each end of the wing. So my first step is almost always to mark the wing so that I avoid a problem. And it's very easy to screw that up. I've been doing this long enough that I know I want them to all be the same. If you did them the wrong way, it would look pretty weird. So my brain is not programmed yet to see them as being upside down if the colors are in the wrong orientation. But I suppose if somebody had been doing it longer, that's possible. So I always start out by just giving myself a quick visual reference. And preferably something that can easily be removed. Gosh, it's like huge to walk across the room to get to the other half. So, and it's nice that it's out of the way now. That's one thing that I've learned as I get into this hobby more and more, is that every time I get done working a plane, and you know what I mean by that, I do the build video series and then I'll do a made and then I'll maybe add some features like what I did on the de Havilland Vampire here. Next thing you know, I'm back to it 6 weeks later doing some more mods, which is what's going to happen here. So I have to have it out of the way so I have my work surface available. So my hope is at some point in my life I'll have enough work surfaces that I don't have to do that. Okay, so the soldering iron's coming up to heat. Got some strippers. First thing you got to do is you'll strip your wires back. And once your wires are stripped, I'm going to go ahead and get into a little bit of flux here. Clean the tip. Get my solder ready. Now, if you guys don't know much about soldering, I've got links on what type of solder to use and all that stuff. You can use a million different types and get the job done. But sometimes it's quite a bit harder to use. If you have the wrong type of solder, it makes soldering miserable. It takes too much heat to melt it. It doesn't cool quick enough, and just lots of different factors to consider. And I don't even fully understand all the details. I just know I've been using this stuff long enough that I'm really happy with it. Okay, so once you've tinned the ends, which is what that's called, then you can, if you have a breadboard, you can do this really easy because one side will be black and one side will be unmarked. So this is unmarked and this is black. So the unmarked side will be our positive, so we'll slide that into the positive line. And then the negative side will come over here. And the way these breadboards work is they're basically just going to allow you to kind of plug wires together real quickly. Okay, so I'm going to trim that off and I'll just slip it in here. Okay, so now I can put my resistor between this black strip. They go all the way together, attached when you use a jumper. So these are all attached and then these are not, and then I attach them with a jumper, and then I have jumpers that go around to the other side, and then they go to my power supply. So in my case, this isn't hooked to anything, so I'm not going to energize it yet. But when I do get it attached, then I can start doing some sampling with my different various resistor sizes, and we'll get there shortly. So while I get this out and get one cut up, that'll be our next step. Actually, let's do that real quick. So I always go to the end of the row because you can use these for other things too, of course. So normally you'd be energizing this with a DC power supply that'd be plugged into the wall because it'd be for a sign. But we have to get these things out of here. I'm not going to mount this to the plane. That'd be ridiculous. It's way too heavy. And you'll be amazed how small this LED is when I get down to the middle of it. So let's do that next. Alright guys, so the first thing I usually do on these is I will very reluctantly use my strippers to cut those up. Okay, once they're cut up, because we need to get to the LED that's in the middle of this dome. Okay, so once you get partway through cutting it up, then this plastic comes off quite a bit easier. And then I will sometimes use a more heavy pair of pliers. And I hope to at least have 2 white lights for the tail light on this plane. These white lights will be significantly brighter than what you see over here that's behind this pole that we looked at the beginning. These are fairly bright, but they're going to be a lot more intense on this plane because I can change the amount of resistance for the current limiting resistor without making them hot. So obviously there's a little bit of power that's being consumed, but it's extremely minimal. And yes, this is the process, and it is definitely a pain in the butt. Of course, you can go buy LEDs, and there's absolutely nothing wrong with that. As you can see, I've bought LEDs before too. But sometimes for me, it's not so much necessarily that I can go buy them, it's that this is actually a really good LED. And so sure, I could go try to find one that's got the same or similar specs, but yeah, I don't exactly know where to find the specs on something that my father-in-law took off of a sign one day, because I don't exactly have a spec sheet on that. If you're ever wondering why I have so many different hand tools here on the shelf, this is an example of how. And then there'll inevitably be somebody in my comment section that says, oh, well, you could do it this way or that. Well, great. I'm sure I could. And I'm sure there probably is easier ways to do this, but this is what you get. The other thing is, you probably aren't going to be doing it with a helmet hanging your camera off your head. And that's the thing. It really does make it somewhat miserable. Okay, so here it is, guys. Jeez, that was a little bit harder than it usually is. Okay, so there's the LED. See how dinky that thing is, guys? And this is what we call a surface mount LED. Okay, because it's a surface mount, I need to keep some of the backing because you will not desolder this successfully most of the time. So you end up with a bunch of wasted time getting to it, and you won't be able to use it. So just don't try. If you do, well, go ahead and try. Go ahead and try. You'll see. You'll ruin a bunch of them. You might get 1 out of 10 to desolder successfully. Okay, then you end up with this extra backing back here, and so you got to do something with that. Well, this is a multi-layer silicone board, so you can come in here, and they will usually split fairly evenly here. See how I'm just kind of supporting it from the back side there? And I'm just trimming off the back half, and it just fell down. Okay, so now we have a very, very, very small light. It's going to be blindingly bright. And yes, I did rhyme just now, but that was a happy accident. So if you flip your light over, you can just evaluate whether or not you got enough material off the back, which I think I did. So we'll go ahead and pause it. I'm going to go ahead and try to free up a couple more, or one more at least, and we'll come right back to you. Since that was tedious, you probably don't want to watch it again. Alright guys, so I got 3 of them done now. You can see they're very small. This is my finger. Okay. And let's compare that to like these lights that came out of my broken equipment here. See how much bigger they are? So that's the reason why I go through so much trouble for these, because they're just like really, really, really small. So we have our negative line here, which has a black wire, black marking on it. So go ahead and strip this up to the end. Now we may not need this much cable, we probably won't. Get a little bit of flux to clean the tip. Mechanically clean it a little bit. And if your wire's crappy, you can get a little flux on the wire, and it'll make it work a little bit better. And we'll grab our positive wire. We'll do exactly the same process. Okay, so we got that tinned up. So now, we don't know what size we need for a resistor yet. So what we'll do is we'll just go ahead and grab a resistor. So why don't we go with this 1/4 watt, 100 ohm resistor. So we'll bridge across this strip here. Bring it over to the negative side. So now we don't have any power on this circuit. I have other stuff that I have on here just so I can see when it's on, and also to simulate some other load, because these things don't work absent everything else. Okay, so we have a BEC that's off of broken ESC, electronic speed control. We'll power up the BEC, which is going to then energize our circuit here. We got our resistor here that's going between our negative wire, and then our positive is coming back to positive. You can see we just have a positive and negative, which is being stolen off of this servo feed that would normally go into the receiver. Okay, so it's not overly complicated. These are live now. So we have a negative in my right hand, we have positive in my left hand. So now we can go ahead and figure out polarity. You won't damage this if it's backward, it just won't work, because it's a light emitting diode. So it just blocks the path of the electron flow. Okay, so negative is on negative, positive is on positive. There it goes. Okay. Very bright. Screws up the saturation on the camera, in fact. Always does. Very bright. Very bright. Okay, so now that we know the polarity, we can de-energize this circuit quickly, and then we can mark our negative on this side. And we mark the negative side rather than the positive side because that's the side we need to see. because that's the side that is going to receive the resistor. So I'm just going to mark that little silicone board that's still attached. Okay. Now I don't know if you guys remember from what I was talking about earlier. My plan was to do 2 or 3, depending on what my process yielded. Well, I got 3, so I'm going to try for 3, and my experience is that the brighter the tail light, the easier you can see your plane while flying. So they are not going to be matched up to the green and the red. They're just going to be whatever they are. And the brighter they are, the better. Because when you're flying away from yourself in a hurry, it's nice to know you're going to be able to see it in a few minutes. So now, in a perfect world, I would just solder these all together in a row like that. But in our real, imperfect world, gosh, this one here has got a lot of backing left on it. I'm going to show you how I deal with that real quick. I take this thing, and now be careful. If it shoots across the room, it's probably gone. Okay. And I just take off a little teeny bit. And if it sands your finger down, you'll live, I hope. That's a lot better. So now, yeah, it's still a little bit deeper. So now I'm going to put these in order for height, because that will help to make it easier to solder. And I think I'm going to try something new today. I think I'm going to make an assembly so it's held still, and then I'm going to do my soldering, because I have such a heck of a time getting these things to hold still. Now that we've figured out the polarity, I think that's going to make it a lot easier. Because every time I do this, it wants to walk away as I'm soldering. And as you can see, guys, it's just really, they're small, very small. So I got to do a little bit of thinking, and I'll come right back to you guys. Alright guys, so I did something strange. I took a piece of white tape, some scrap I had, and I went to initially my kicker and regular non-foam safe medium CA. And so I put a strip of it, and I thought, oh, what if I just use mucilage? So I took this mucilage, that's the large bottle, and I took off the lid like this, okay, very simple, and then I grabbed a new fresh toothpick, and then I stabbed it in there and grabbed a little bit, and I just made my own little double-sided tape, and then I picked them up and stuck them exactly in position, which we shall see if my method worked. My guess is it probably will hold better than double-sided tape, because that mucilage is pretty bulletproof. And then when I'm done, I can just cut the tape. So we'll see, guys. We will live and see. Keeping in mind that 3 of these in parallel, with only one current limiting resistor, we're going to have to change the size of the current limiting resistor to get the right brightness. So let's do that after we're done soldering this. So we're going to tin this line up here. We're going to actually apply a little bit of flux directly to it. Makes this stuff just so much easier to work with. Okay, great. So now that we've got that done, we can come in here like this and try to solder that thing in there. I'm going to clean this tip. It's super dirty again. It's been 30 seconds. Why wouldn't it be? Okay, so we're going to let that cool for a second. I think I got all 3 points, but it's kind of hard to tell at this point. And the only way to really test that's easy, before you get ready to solder the other side is to just grab your wire. Yes, yes, yes. Boom, boom, boom. Okay. So now we go ahead and de-energize the circuit. And we come back and do the same thing on the positive side. And to be honest with you guys, this is probably the easiest time I've ever had with this particular step. So I hope that's a thing. I hope that things will keep up that way. Okay, so we're going to try to touch this to the positive wire of the first one. Got it. Second, third. Alright, I'll be amazed if that got all three, but it's possible. Oh, we got the third one to do. So now, usually I kind of have to reluctantly do this while it's energized. And reluctantly in case it would melt the other two connection points. You could potentially create a short circuit, and short circuit's not usually a great thing. Okay, got it. Okay, so now we can shut this off. And guys, that's going to conclude our video for this period. Doesn't look too amazing yet. But when it's on the back side of that plane, it's going to be awesome. And we'll pick it up on the next video. Thanks for watching. Don't forget to like and subscribe. Also, check the link in the description below. Buy one of these for yourself. We got a much better price point this time than the ASW. And also go a little further down, you can see the receiver. And obviously these lights I'm scavenging. But when we get to the red and green, just ask me. I'll tell you where to get them if you want to. Thanks for watching, guys. Come back for more on the Phoenix 2.6. Phoenix Evolution.